Okay, so I am way behind. I didn't quite realize what I was getting myself into to decide to stream these, and it looks like I'm probably never going to catch up. So no promises on how many more of these I'm going to do, because it takes quite a bit of time out of my day. And on top of that, I am trying to post these all to YouTube, so I'm a little bit behind on that as well. But I have about an hour. Actually, I have maximum 1 hour. So let's just go ahead and jump into it. So we are working on day 9, Smoke Basin. These caves seem to be lava tubes. Parts are still even still volcanically active. Small hydrothermal vents release smoke into the cave that slowly settles like rain. If you can model how the smoke flows through the caves, you might be able to avoid it and be that much safer. The submarine generates a height map of the floor of the nearby caves for you, your puzzle input. Smoke flows from the lowest point of the area to the lowest point of the area that it's in. For example, consider the following height map. Let me copy that. Each number corresponds to the height of a particular location, where 9 is the highest and 0 is the lowest. Your first goal is to find the low points, the locations that are lower than any of its adjacent locations. So up, down, left, and right, no diagonals. Locations on the edge or corner of the map have 3 or 2 adjacent locations, respectively, and diagonal doesn't count. In the first example, there are 4 low points, all highlighted, and then I assume we have to... Okay, then we calculate the risk level of a low point is 1 plus its height. In the above example, the risk levels of all low points are 2, 1, 6, and 6, and then you sum them. Okay, so let's go ahead and get started. I will jump over to Advent of Code. We are working in, oops, don't need that. Sources, day 7, day 8. Let's add day 09. Okay, so I really am not quite sure why it likes to hang up when opening a blank Swift file. It has to be syntactic, but I kind of require that for syntax checking. So enum day 9, static func run, and we will get our input, which will be read file day9.test. We will go over to our resources and add day9.test. And then go back to this. We'll just print it out for now. And then go over to main.swift and then comment that out. Day9.run. Okay. So let's build it and run it. And we see our puzzle input. Okay. So looking at that puzzle input, we essentially have something like a height map. And this would have, we need to know what the numbers are, sorry, what the coordinates are of the given numbers. So we could read in each row, and then we could have something like values as a 2D array of ints. That's one option we could go with. Alternatively, I could do values as a single array of ints, and then store the width and the height, and then have a function to read in the coordinates of a given number, which is also fairly easy. I think this one is probably easier to parse. Let's just go with that one for now. Okay, so I need to be able to create a height map with a bunch of values and then say print that out. So yeah, let's do that. We will say input.lines.map. We're going to map each line to an array of the characters, and then map that to int.init, and that'll give me the numbers. And I need to use compact map because one might not be a number. That will give me an array of the numbers for this line. And then the outer one gives me an array of all the lines. So that would be the values. And then we can say let map equals height map values values. Okay, and let's see, lines is an array of strings, yes. And then I want to get each line input.lines is an array of strings. I want to map each. So this should be a string, right? Is that not correct? I want to get all the characters in the line here. So I could probably just do that line.compact map. And can't convert type of, yeah. Let's do int $0. Not quite sure what I'm missing here. Input is a string. I get all the lines out of that string. Map each one to... What am I missing? Let's try and be explicit. So this will be, this needs to be, this is a character. So I need to do a string like that. There we go. Okay. Now we can get rid of this. Okay. So that gives me my values, then I do that, and then we can print out the map and just make sure that we're still able to see everything, and we are. So the first row is 2, 1, 9, 9, ending in 0. Yep, okay. So now I want to produce the, I suppose, the differences in... Because we need to know if something is a low point, then all of its neighbors are greater than it. And so if we look at the puzzle input, it's probably gigantic. Yeah. And if we end up with a solution where we have like, I don't know what it is, like 100 by 100, and each cell we're doing a check against its neighbors, could be quite inefficient. Maybe a better way to do this. Also, because we're already iterating over it here, it's possible that we could just pre-compute this as we're iterating. I'm not quite sure which would be more appropriate here. I think part of it is we just need to see it be slow or fail first. So what are we trying to get? We're trying to get the low points. And that's going to be an array of ints. So let's just brute force it for now and see what happens. So we're going to go for... let's see. Oh, actually, there's some things that we can do here to make this better. Because if something is a low point, then we know that none of its neighbors are a low point. So it's kind of like Minesweeper in that sense. Like you're getting some intuition about the remaining cells. And so we can skip over those. So say I check the first cell in the list and I realize that it's not a low point, then that means that potentially its neighbors are. But if it is a low point, I can skip over its neighbor. And skipping over the neighbor in the next row is going to be a little trickier. So I wonder if I need to perhaps store... I could store a flag instead of having each one of these be an int. I could store like a flag that keeps track of whether it's a low point or not. And if it is, and that would have to be nillable, so it hasn't been checked yet. And then we could just iterate through all the values and skip over calculating the ones that are already denoted as not a low point. There's got to be a mathematical way to make this a little bit easier. Part of me thinks I need to like map this entire array to an array of like the differences between the neighbors. But in that case, I would have to have a difference for each direction. And then once I had that, then I can filter all the results that are correct. Yeah, I do want to design something that can skip over. Let's see. We could keep track of. So the low points here could keep track of the low points and the known high points. Something like that. And this would actually be a set of ints because we would want to see if this number, either that or the known high point index. Because the number isn't unique, right? But the index is. So known high point indices is going to be a set of ints. And then we can iterate over this. So we'd say for x, or for row in values, for col in values. These indices, now I need actually a tuple of row and column. Values, okay. So at this point, if this is a known high point, if this contains a tuple of row column, then we'll continue. Put that on a new line to make it a little easier to see that we're breaking out there. Okay, so then we'll continue there. If it is not, then we need to compute its neighbors. Is that true? This doesn't conform to protocol hashable? Wow. Okay. In that case, we could go back to storing them as a single array. Let me just make a coordinate struct real quick that is hashable. And it has a row and a column. And then this one is a set of coordinates. I think I might need this. Row is row, col is column. If we contain this coordinate, then we'll continue. What am I doing wrong? Oh. This needs to be dot enumerated. So we get row index row. And then this also needs to be enumerated. Oh, I don't want to do that. I want to do row in 0 to values.count. That's what I want, because I don't need the actual value. And this is going to be for column in values for that row.count. 0 dot dot less than. Okay, that's what I wanted. Okay. Okay, so at this point we know that it's not a known high point. Let's return our low points here. If we then check each neighbor, So we'll have to have a function to get the coordinates. So this would be func neighbors for coordinate. It gives me a set of coordinates. Okay, we will return neighbors. So now for this coordinate, if the coordinate dot row is 0 or greater than 0 rather, then we can add neighbors dot is it insert on a set? Yeah, we'll insert the row and column. So this will be a init. Row will be coordinate. Yeah, I'm going to call it C because I think it should be obvious. This will be C.row -1. And then column will be C.col. Okay, so then if C.column is greater than 0, then we'll go to the left. This is the type of thing that I think could perhaps be a little bit easier. Or maybe we just insert them all and then filter out the ones that are negative, maybe. I don't know. So in this case, we'll do column -1. If the C.row is less than the entire width, values.count, or sorry, height, I mean, and -1, then we have room to add the neighbors for C.row +1, call C.col +1, no, call, and then we have one more for the column. So this will be, we'll just grab the first one out of the array. So this would assume that we actually have at least one row. Let's do guard values dot, not values dot is empty, else return an empty set. Okay, so this would be same row and new column. Okay, and then we return neighbors. Okay, so then we can say for each neighbor, for neighbor and neighbors for coordinate, let's see, is this always, so it's the one that's less than all of its neighbors. So there could never be two low points in a row, I don't think. Like if one is, yeah, so that's, it's guaranteed that we need to make sure that we check the value at this neighbor. We need to know the coordinate and the value. So this would be something like neighbors for coordinate. And then map each one of those to a tuple of $0 and the value at that coordinate. So that would be height at $0. So let's do func height at coordinate gives me an int. This returns to me value at coordinate.row, then coordinate.col. So now I've got an array of tuples that gives me the coordinate and the height at that coordinate. So this is, I don't know, neighbor heights, something like that. And if neighbor heights dot all satisfy, $0 dot let's make these coordinate. We'll do chord and height. $0.height is less than this coordinate dot height. Sorry, if all of them are greater. What's wrong with that? Value type height map dot coordinate to set of height map coordinate has no member at all satisfied. Height at coordinate returns an int. This should be an array of tuples of coordinate and int. Is that not correct? It is. Coordinate dot, oh yeah, that's true. Okay. This needs to be height at this coordinate. And we don't need to calculate that so multiple times. So we'll just do that once. Height at chord gives me that. If all of my neighbors are higher than me, then now we know that this is a low point. We will append the height onto here, and then we need to mark all of the neighbors as known high points. What's wrong? Cannot call function non-function of type height. I don't understand why it's. Let me just double check something. If I change this name, does that fix that error? Value of type height map dot coordinate. This is neighbor heights. That's why. So for each neighbor height, I should be able to do $0.height, which gives me an int. Height map coordinate int. It won't let me read these. I wonder if I get rid of that if it works. It does. Okay, so by giving it the type here, it erased the labels that I put on the tuple there, which was a little bit unexpected, but. Okay, so now that we know that all of the neighbors for this are high points, so we can say known high point indices dot. What else do we have on set? Can I add many? Insert new. We can combine a set with a union. That returns a new set. This form union updates it. So we could say form union with neighbors. Neighbors are I need to say neighbors is neighbors for coordinates. Okay. Okay, so then the next time through the loop, even though we're still iterating over all these loops, we jump right out if we already know that this is a high point, and then we return the low points. And then we can print out map.lowpoints, and then print out the sum of low points is map.lowPoints points dot reduce 0 plus. Okay, let's run it. We get 11, which is not correct. 1055. What did it say that we were? There were 4 low points. Oh. Oh, yeah, I need to calculate the risk of the low points. That's what it was. The risk of a low point is 1 plus its height. So low points, we could say something like low point risk is low points dot map. Okay. Then up at the top, we can grab the low points, and then we can say risk is low points risk. This is going to do it twice, which I don't want to do. So we'll call that risks. Low point risks. Let's do that. Low point risks. Okay, sum of low points was 15, which I think is correct. Okay, so let's grab our puzzle input. We'll grab this. We will go add that over to here, day 9 dot input. Paste that in. We will go back to day 9 and we'll change our input here to input. Okay, I want to run this in terminal because I wasn't quite sure how long it would take, but okay. Sum is 417. Let's see if we got that correct. Okay, let's continue to part 2. Next, you need to find the largest basins so you know what areas are most important to avoid. A basin is all locations that eventually flow downward to a single low point. Therefore, every low point has a basin, although some basins are very small. All locations that eventually flow downward to a single low point. Therefore, every low point has a basin, although some basins are very small. Locations of height 9 do not count as being in a basin, and all other locations will always be part of exactly one basin. Now I feel like I am even more wanting to have a different data structure for this other than the heights. Something about the difference of the neighbors would perhaps help me here. The size of the basin is the number of locations within the basin, including the low point. The example above has 4 basins. The top left basin is size 3. So we basically keep going. As long as it continues to increase, we keep going. And then once something is already part of a basin, we don't count it again. Top right basin, so let's say if I'm going left, I'm going to keep going to the left. Okay. Find the 3 largest basins and multiply their sizes together. Okay. This is very much like Minesweeper, actually. Okay, so we're going to have a function find basins. And this is going to return an array of basin sizes, right? Multiply their sizes together. So yeah, this is going to give me how many basins there are and their size. So it's going to be kind of a similar structure here, but we, instead of known high point indices, we need to know if something is already in a basin. So this is going to be known basin indices will be a set of coordinates. And then we will have basins like that, and we will return basins at the end. Okay, so then every time through, instead of getting neighbors for a coordinate, I kind of want to have directions. Like, let's check left here. And so this will say, while there is a neighbor at that coordinate. This would be coordinate, what do we call it? Coordinate at? Did we do that one? We didn't. Okay, let's let our C equals column. And then we'll say while let left neighbor coordinate equals, no, we'll say while C is greater than or equal to 0. So we need to go left of us, so we're going to do that. And then C is going to minus equals 1 every time because we're moving to the left. So this needs to get that neighbor. So that's going to be the height for this neighbor is going to be height at this new coordinate, which is going to be row is the current row we're on, and column is C, the one we're iterating over. If height is, we also need to know which height we're checking against. So current height is equal to this height, which I want to move up to here. We'll call this low point height. Then we'll have, we'll start out at the low point height. And then as long as we have room to go, let's see, we'll get the height at the neighbor. If the height for the neighbor is greater than the current height, then we need to add this to the basin. Let's see, this is going to be, say, current basin count is 1, right? Let's see, we don't know we're at a low point height at this point, but let's just assume that it is. Do we need to find all the low points first? We do, and then go from there outward. Because I can't start at the edge, because if the one to the right of it, if the one to the right of it is less than, then this isn't a low point, and we shouldn't start from here. So I think, so our low points here are returning the values, not the coordinates. So I would have to change this to return coordinates. Find those first, and then move outward from there. It seems even less efficient to be iterating twice over this. But there are far fewer low points to start from than starting from every single one and counting outward. So I think that that is probably an okay thing to consider. So low points now returns coordinates. So here this would return coordinate. Low point risks, this now would return the coordinate in, and we'd need to get the height for that coordinate. So we'd say height at C. And then we'd map that to the risk level, which is that value plus 1. Okay, so if I have that now, then instead of looping over everything, we can say for low point in low points, then we get the height. Yeah, this is going to be better. Okay, so we'll start checking left. So while we have room to move to the left, we will get the height at that position. If that height is greater than the current height, then our current basin count increases, and we need to add this. We need to add this cell or this coordinate to our known. We didn't call it high point indices. Known basin indices. Yeah, known basin indices. Insert this coordinate. Neighbor chord is this. Okay. Insert neighbor chord. Okay. We don't need the let here. We need to know what the low point. So this is a coordinate, so this has a column. And this is height at low point. And this is low point dot row. Okay, we have some stuff here that I want to get rid of. Okay, so at this point, C needs to be of R. So at this point, we are only checking all the low points and that the ones to the left of it. Then I need to iterate again for to the right. And there's going to be considerable duplication here. So I think what we just want is a function to give me the coordinate and the value given an offset. Because then I could pass in a coordinate offset of 1 or 0 in the row or column direction and get back not only the coordinate but the value. So this would be look. Let's call it look, and this will give me at an offset of a coordinate, I guess. We could do that. And this gives me a coordinate and the height, perhaps. Int. I'm not sure if I really need to do that because I can just ask for the height after, but... And this might return nil if there isn't one in that direction. Okay, so then I can say I need to know where to start from. From coordinate, offset. So if I say let new coordinate is from plus offset, and then we can add an extension on coordinate, func plus other coordinate. Is that gonna work? And then I need to return a coordinate. Do I need this to be static func plus with left-hand side coordinate, right-hand side? I think I do. Yeah, okay, so this will return row of left-hand side dot row plus right-hand side dot row. Plus cannot be applied to 2. Isn't that how I am supposed to be able to do this? Coordinate has no member row. Ah, it's inside of here. Let's just move that out for a second. Yeah. Okay. Invalid redirection of coordinate. Okay, so there is a coordinate somewhere else. I don't have a coordinate type, do I? I have one on day 9 and day 5. That's why. Okay, in day 5, what does my coordinate look like? This is sort of why I wanted to hashable, equatable, parse, return, debug, description. This is actually all valid, except I called it X and Y. I really don't have time to refactor this at the moment, but I do think that we could probably use both. So let's go grab, let's do it in here, and I will extend heightmap.coordinate here. And this will be self. Can I do that? Yeah. Okay. Back over on our look function. So now we've got from plus offset. We need to know if it's a valid coordinate. So let's do func is valid coordinate. C coordinate returns a bool. And then here we will return c.column is within the range, so it's greater than or equal to 0. And c.column is less than the width of our entire map. So we can say map width int. Let's also do map height. That's going to be values.count. This is going to be guard let, actually we could just values.first.count or 0. C.row is greater than or equal to 0, and C.row is less than map height. I don't need the return in there at all. Okay, so now I can say guard is valid coordinate, new coordinate, else return nil. So now when we look in a direction, we can get that. And now I can return the new coordinate and the height at that new coordinate. Okay, so now we don't need the while loop. Do we? Let's see. So if I say var left is the coordinate to my left, then I can say look at, let's have a current point that we're looking at. So this is going to start at the low point. And while, we could say while let left equals look to the left from current. Look from current to, what do we call it? Offset. Offset is going to be a init with a column of -1, row 0. So this is going to give me the leftmost point. And it's going to stop if there isn't one. So we have the coordinate already. We have the height already. So now we just need to know if left.height, and I wonder if I should give these, yeah, chord height Let's check left. If left.height is greater than the current height, then this is part of the current basin. We will insert left.coordinate, and then we will set current equals the current left coordinate so that we continue searching. If it's not greater than the current height, and I think we need to update the current height as well. Current height equals left.height. If it's not, then we can break out of this loop, right? So we'll start at the low point height as well. Okay. I don't have much time left. I hope I can get to an answer here. So this needs to be row 0, column 1, -1. We can get rid of this. We'll check right in a second. Okay, so now we're back to working. It's got this look function that we can use to look at a given coordinate and return its height. So if we look to the left and there is one, and the height is greater than the current height, then we increment the basin count for this basin. We insert this coordinate so we don't process it again. We set the current height to the one we're looking at now, and we set the current one that we're working on now so that it'll continue to work for left, continuing to increase the basin count until we're done. So at this point, we need to do the exact same thing for up, right, down, and left. So it seems to me like we could have our offsets be an array of coordinates and have this be row 0 call -1, row 0 call 1, row -1 call 0, and row +1 call 0. And if we have this, so we have -1, 1, -1, 1, 0, 0. Okay, so if we have all these offsets, we can say for offset in, or for direction maybe. Yeah. We'll call that target. The offset will be our direction. While target.height is greater than that, target coordinate, target height, then we'll break and we'll process the next direction. Then we return the basins. Okay, let's go back to our test input. At this point, we would say that we have the basins is map.findBasins. We can print out basins is basins, and then I think we need to find the 3 biggest basins. So we could probably say basins.sort sorted.reversed and take the first 3 of them. Let biggest basins is that. Print biggest 3 are biggest basins. Let's run that. Okay, array index is out of range. Let's see, where did that happen? So the basins return an empty array. So we'll say guard let, or guard basins.count is greater than or equal to 3, else return. Okay, so we still have a problem with the basins. We start from all the low points. We have a current basin count. Yeah, at the end of our while loop for each direction. No, after we're processing all the directions, we will say basins plus basins.append the current basin count. I don't like count here. I kind of current basin size. Okay, and then we do need to reset here before we start looking in a direction. We need to reset the current and the current height starting at the low point when we go in each direction. Okay. Is this going to work? Biggest three, 11, 9, and 8. No. So do we need to do them in a certain order? Because if you do one in, let's see, the total basins were 4, 9, 11, and 8, which is not correct. So top left basin size is 3. So we could at least start with that one. If we started with this, this low point here, low points, 2, 1, 6, and 6. No, that was the risks, wasn't it? Ding. Let me check. We are printing out the risks. We are. I just don't necessarily want to continually compute the low points, but I suppose for debugging it's not a big deal. So this is risks. Let's go grab low points as well. Low points, just to make sure that we have the correct values for those. Map.low points. Okay. And we need to actually map those to map.height at $0 so that we can actually see what the numbers are. Okay, 1055. That was correct, right? First row, 1 and a 0, third row, 5, bottom row, 5. 1055. Yes. Okay, so for the first one, if we look to the left, that's the end of that basin. If we look to the right, it can't count. Oh, it said that we can't count 9s, right? Yeah, okay, sweet. Okay, so let's just skip all the 9s. Target.height is not equal to 9. Okay, biggest 3, 7, 7, 6. That doesn't actually seem correct either, does it? 9, 14, and 9. So yeah, this is not correct. All right, I have about 10 more minutes. I'm probably not going to finish, but let's see if we can at least get to what potentially could be wrong here. So just looking at the output here, this is correct. This is correct. This is correct. The basin count is off by 1 for at least this one. So if we just trace that when we're calculating the basins, so we are print starting from current, looking in direction dir, then print, let's grab let's just grab what the current height is at this level. Target.height. So we can see, we should be able to see where it's iterating from for this. Okay. So starting from 0 and 1, and we're going to the left, it finds a 2, which is correct. Let's grab this and this here. Okay. It finds a 2, that's correct. And then it starts over because there's no more in that direction. So it's starting there and it's looking to the right. It finds a 9, that's correct. And so then it looks up and doesn't find anything, and it looks down and finds a 9. Oh, shoot. The 2, I need to check. I don't always start at the low point. I need to check from the left, then I need to go from there in every direction. This seems like it would be even worse than I thought. Okay. So somehow I need to know to reset it, like when I'm done. But I suppose that I could say I'm just wondering, can this like snake outward? Suppose it could. So for each one, you just keep going in every direction. Until you found an edge, one that's not higher than you, or a 9. So if I avoid setting current every direction, it would actually continue going left from current. But every time we look at a different one, we got to start and do the directions again. I think that this is a recursive problem. So given a position, you could say, kind of similar to finding that all of the neighbors satisfy a given condition, to make sure that this height is lower than those. This would say, give me all the neighbors that slope upward, and then just continue. So you could say neighbors sloping upward from coordinate gives you an array of coordinates. And then we would have these directions, and that look function could potentially, let's just say that is a function we can use outside of here. If I had neighbors sloping upward from a coordinate, and I could say, given all of my neighbors, I do have neighbors for coordinate. Yeah, let's say given all of the neighbors for this coordinate, neighbors for from, where the height filter, where $0, height at $0, height at from, height at $0 is greater than height, and that the height, their height is less than, let's do this in 2 steps. Get the height is height at n, and this is going to return height not equal 9, and height is less than the starting height. And that's going to return all the neighbors sloping upward. Okay. We'll call this this height. Okay, so this will give us this gives us immediate neighbors sloping upward, right? But then I want to take all of those neighbors and run it through again until I have none left. So now that I have all the neighbors, I'm going to flat map this neighbor but I need to avoid iterating over the same coordinate again. I want to do neighbors sloping upward from n. But I don't want to do that if I've already iterated over that. I think because the slopes will guarantee that they will stop, but I can't count the neighbors twice. I'm not quite sure how to do that in a functional way without just iterating and checking against the set. So we could say results, let's say all unless I map it to a set, but then I'm still trying to append and processing one potentially multiple times. Actually, the filter may be taking care of that for me, because I'm never going to return any neighbors that aren't Yeah, I do think it's possible for me to get duplicates in here, actually. Because if two of them actually slope upward to the same point, I don't want to include those. And then that would potentially make me process way too many results. Gosh, I don't have much time. let's see. What am I going to do for time? Okay, so let's say for n in neighbors for this. I'm going to this would actually have to be a set so that I could easily check if something already contains that. Okay, so that gives me my for loop. And then I can say, it's kind of hard to read. This gives me all my filtered neighbors. Let's do this in 2 steps. Filtered neighbors. Okay. If not results dot contains n, then we're going to add all the results. We need to call it again and then append all of those to results.insert $0. Not for each. This will be for each. Results.insert. I don't know if this actually fixes the problem, because in this, you don't know if your results contain from a previous one. I'm not quite sure, but I don't have any more time to work on this. So let's get the syntax working. And I will have to continue this perhaps tomorrow. It doesn't like insert here. For each results.insert $0. And okay, so this neighbor's sloping upward from coordinate starts at the height that we're starting from, then gets all of the neighbors whose height is greater than this height, but it's not a 9 because we can't count the 9 in there. And then for each one of those filtered neighbors, we make sure that our results don't contain that neighbor, and then we will continue grabbing each neighbor sloping upward from that point. And then for each one of those, we insert into the results set. And at the very end, I want to return that as this as an array. And I'm not quite sure why I can't do this. Let me just quickly drop into a playground so I can see this. One of the weak points of using Vim is, there are certain things that I'm just realizing that I'm just really dependent on code completion to sort of give me things that I need. So let's say I have a set, which is a set of strings or whatever, and I want an array of strings. And so I say array of set. Let me call this S. And this works. So why is it complaining here? No exact calls to initializer. So we're trying to return an array of coordinates, and I have a set of coordinates. Yeah. That should work. Is it something that needs foundation for it to work? Looks like no. Okay, so we actually get more details if we do a Swift build here. So it says no exact calls, no exact matches in call. Candidate requires that height map.coordinate conform to sequence. Requires a height map.coordinate. So this is the type that it's trying to return. Do I have something? Oh, this needs to be results. I don't know why I did it like that. Okay. Yeah, duh. It was trying to take this function reference and wrap that in an array. Okay, so that's why I have that. Okay, so now we can build. And if we run it, we are outputting our work as we're going. So we're starting from this coordinate. So let's bring up the map so we can see it. Starting from the row 0, column 1, this is the low point that we found right here. And then we're looking in the left direction, we find a 2. So starting from there, looking in the direction, we find a 1. So it's going backwards to find a 1. But it's looking for things that are higher than it, so it won't continue. So now we see that this one, oh, then it finds a 3. And then a 9. Okay, so this is like it reaching out in the left direction. Sorry, in the right direction it finds a 2 and stops. Now it's going in the direction to the... Yeah, it goes left, stops. Now it's looking right, stops. Now it's looking up, stops. Now it's looking down. And it finds 3 and 9 stops there. Then starting from coordinate row 0, column 9. Why is it starting there? Row 0, column 9. Oh, it's doing the next basin. Okay, so I think we need to output like that first basin. What is it doing here? Find basins, starting from da 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 da. Okay, so print basin found, and current basin size. Okay, let's go back to terminal and run it. Okay, so it found this basin of 3, and now it's starting from the other one, and the next one it found was 5. But that's not correct, because we need... Okay, so starting from row 0, column 9, which is this guy, it's looking in the direction left, and it finds 1, 2, 3, 4, 9. 1, 2, 3, 4, 9. Then it's starting from row 0, column 5. So 0, 1, 2, 3, 4, 5. So it's starting at this 4 here. And it's looking in the direction to the right, and it finds a 3. I think, it's kind of... It would be probably a good idea for me to say, like, I already came from the right. I don't need to check that one again. But it does find that it's lower, and so then it's like, okay... Starting from that position, now we're looking at up and stops, and now it's looking down and it finds a 9 and stops. But that's where it ends, and what we need it to do is actually continue so it's continuing from here. This one, it needs to check every direction. It waits until it gets to the very end and then checks all of those directions. But it never goes from coordinate 6 before it bails out and says, oh, I'm finished with this basin. Okay, so so we start at the low point. We have every direction. For each direction, yeah, I think, yeah, so we're looking in that direction until we get to the end. And for each one, we do see all of those numbers, so that's what this print target height is. And if the target height is greater than the current height, and the target height is not 9, then we will insert this into the known basin coordinates. But then it breaks here, and we need to continue. Am I not finding the neighbors sloping upward function? No, I'm not even calling this yet. Okay, so I think I need to neighbors sloping upwards. Find neighbors for yeah, I think that I don't need any of this anymore. If I'm using neighbors sloping upwards. Okay, let me comment out all this stuff. Basin coordinates, maybe? So we're going to say starting from low point, and we'll pass in low point. And then we'll have basin coordinates be basin coordinates like that. And I kind of want to go over to my coordinate type, which is where here, and make this custom string convertible. Just to make this a little bit easier to read. So we're going to say X, Y, no, row, column, column, row. I don't want to do I want to do X, Y? Before I was showing row, column. Yeah, I'll do it column first, and then row. Okay, so that builds. Let's go to terminal and run it. So here's all the low points we found. Starting from the low point at 1, 0. Didn't find any basin coordinates, so let's continue debugging that one. Neighbors sloping upward from low point. So we get this guy, we find all the neighbors. So let's just say printing neighbors sloping upwards from We'll see what this shows us. And then we'll say filtered neighbors. Let's just call it filtered neighbors so we can see what's going on there. So looking at the very first one, filtered neighbors was 0. Starting from this position, filtered neighbors gave me this one only, which is correct. And then it's saying sloping upwards from that one gives me 0, 1, which is correct. And then sloping upwards from there gives me nothing, which is great. So for each time through, I've returned my results. Do I never insert this one neighbor? I need to insert this one neighbor. Yeah. Otherwise, I'm just going to return empty at the very end. Okay, so let's find this first one again. Starting from this low point, we find the left one, which is correct. Sloping upwards from that point, we get 0 and 1. It's still returning. How is that? Basin coordinates. Oh, I did find it. 0, 0, and 0, 1. So 0, 0, 0, 1, and we also need 1, 0. So that needs, okay, so we find the neighbors sloping upwards. We need to also add in this point, because that's part of the basin. Okay, and then, so then the current basin size is the size of all of these. Okay, I'm pretty sure this is working. So current basin size, we don't need known basin indices anymore, or do we? We do, because we need to make sure that we skip over any that were already included in that. Okay, so we'll say known basin indices dot form union actually, let's see, what does a set have for adding contents of an array? We've got insert new member. We have form union with another sequence. Yeah, that does work. Okay. Form union with basin coordinates. I don't like indices here. That should be chords. Okay, so starting from low point, basin coordinates are here. And then the current basin size we don't have anymore. So this one is going to be basin coordinates dot count. Okay. Build, and let's run it. So we found 3, and then the next one we found was 9, which is correct. The one after that was 14. I think that's correct. Yes. And then 9 at the very end. Sweet. Okay, let's go back here. I just realized that since I'm in terminal vim, my build command for Swift build is leader SB, which is a little bit much, but I have access to the command key. So I wonder if I do command B just in my vimr setup. So this would be command B to build in Swift. And you could do stuff like only if the file type that I'm in is Swift or whatever. But I think for the most part, it would be fine. God, this is really annoying. So in normal mode, silent, command B will do whatever my Swift build was. I guess I could just do it like this. Swift build carriage return. And then I could do the same thing for R. Swift run. Okay, let's try it. Command B. Is it because that's lowercase? Possibly. Yeah. Sweet. Okay. So building works, running works, but it is something. Oh, maybe because it's silent. I don't think I want it to be silent. Interesting. Okay. The build part is useful, but that isn't. Okay. Let me get rid of all of this intermediate debugging print statements, and then we're going to go over to day 9 input. We're trying to find the biggest 3 basins, I think, and then multiply them together. So we'll say that the biggest 3 are the biggest basins, and then we'll say the basin product is biggest basins, which are going to, what is this outputting right now? Just an array of integers. So we just need to reduce starting at 1 times to get the product. Oh, 1 lives left. Rating with a party of 21. Wow. Welcome. I'm curious what you guys were watching before. Okay, let's do this, and we'll go over and run it. And we have a basin product of this, which I'm hoping is correct. Okay, good timing too, because we just finished day 9. So now we're going to go on to day 10.